Good afternoon, good evening, good morning from wherever you're joining us from today. Welcome to a Microsoft Reactor live stream event. Apologies for the delay. We had some technical difficulties. So welcome back to another episode of In the Code Garden with Renee Noble, who is our regional cloud advocate at the Reactor in Sydney. So we'll be continuing on from last week's topic, which Renee will go into some more detail with you in a second. Firstly, a bit of background for whoever's joining us for the first time today. So as mentioned, Renee is the regional cloud advocate for the Sydney Reactor and the Australia region. She's passionate about technology, education, community, and bringing them all together in person and online. Renee has worked in sectors across tech, outreach, and education. She's also worked in ML and web development in the past, dabbles in embedded tech, and is always keen to learn more. So besides teaching and tech, she loves swing dancing, cats, and having a ridiculous number of plants. We'll be speaking today for about 25 minutes with some time for question. However, do ask us as many questions as you can throughout in the comment section. Thank you for everyone hanging in there whilst we were delayed. I can see you've all said hello and where you're coming from today. We will be adding additional links into the Q&A section as well. So the additional resources from Renee's presentation as she speaks, I will add them to the comment section, and we'll also add the link to the survey with the event code towards the end. And if there's anything that you missed from today, you can watch it back on the on-demand version, and I'll share with you the YouTube link for that shortly. But for now, I'll hand the floor over to Renee to kick it off. So thank you so much, and over to you.
Thank you, Sarah, and thank you for running through that intro, even though I know you're out of breath from running around trying to get into your house. But we're here now, and we're going to talk about Python, and it's going to be awesome because we're going to be doing some awesome data visualization today. So let's kick it off. So today in the Code Garden, we're going to be talking about graphs and why they're important and how to use graphs the right way. Some like etiquette around graphs as well. Then we're going to cover 3 different kinds of graphs in Matplotlib and kind of some of the fun or like useful things you can do with Matplotlib, because really you can do anything you want with Matplotlib is what my takeaway is from it so far from the things that I've done. And yeah, whatever you want to do, I'm sure there's a way to figure out what to do it, but we're going to get you started with some scatter plots, some bar charts, some line graphs, and then playing around with your axes titles and your headers and your margins, and maybe doing a little bit of playing around with the labels on them as well, because sometimes you want to change up what it says and you don't want just what the data says straight. So that's what we're going to be doing today. So today our tools in the garden are going to be a Visual Studio Code with the Python extension installed, Jupyter Notebooks, and we've got our green data set. So they're coming back from last week. And yeah, well, if you were here last week, we used the Cairns ocean surface temperature. We have the U2 Tesla battery readings, and we have some koala observations. We do have our first question in the chat from Robert Rabin, who's saying, why is Microsoft not using C#? And Microsoft really supports you using any language, and there's a lot of different things out there that do a lot of different things well, and we want to facilitate everyone to utilize those. So yeah, here we are doing Python. I love Python. It's been my language of choice since really I started programming. So yeah, it's Python in the Code Garden today. So let's talk about why use a graph. And here are some excellent graphs that we have here. And the reason I'm showing you these particular graphs is because each of these actually has the same mean. They have the same average. And last week in the Code Garden, we were talking about processing data with NumPy and Pandas and things like that. And we took some means and max and min and medians and all those kinds of statistical things. But the thing is, if you don't take a look at your data, you can be quick to find out that, you might not find out at all actually, that there's actually some other trend going on, and it's really not useful to take the median of something or the mean of something, or to plot something with a linear line like this, because there's a lot of different things happening here, whether it's outliers, some other trend, and just clumps of data. We have a lot of different things happening. So we need to have a look at our data because it's really here to tell us a story, and you really can't just, most of the time I'd be hesitant to boil down any data to one number because there's so many more dimensions and things to consider, the context that is around the data. So we're going to learn how to graph some things today because it's going to be super useful for bringing you enlightenment, I'm going to call it, from your data, shining the sun on it. But we're going to talk about some graphs I'm not going to show you today. I'm going to call them the bad graphs. Not that I don't like them. I don't use them because I know that they're not good for communicating to humans. So we're talking about your dessert named graphs. So you've got your pie chart and your donut chart. They are not, sadly, they're not good at communicating to humans the actual, depths of the data. Because, well, humans are bad at some things. Humans are bad at determining size from angles. So, for instance, there's a lot going on here in terms of, there's a big angle here from this graph that I've grabbed from the internet, from the University of Melbourne. And then Facebook looks absolutely huge, but we also can't be bothered to look at these other ones because they're so small. It can kind of be hard to map visually what the label is to that tiny wedge, because you have to kind of look at it and it's kind of at a weird angle. Also, you have this whole angle, but there's also a different volume going on in this giant wedge. And are we looking at angles? Are we looking at volumes? When we know about our circle geometry, we know how things come out differently, because it's not just like a linear relationship. So yeah, it's a bit of a problem. And then you kind of just don't bother to look at these small things because you're like, well, in this graph, for instance, Facebook and YouTube, they're huge. They've got such a big market share. Why would I bother looking at the rest of them? They're probably negligible. But then you lose that nuance in the data. So we can look at the same data on a different graph, same data, different layout, and it's a lot easier to look at actually. And you can kind of pick up the details. You can look at the other bits and pieces and compare these smaller market share social media platforms much easier, and you don't feel swamped and just keep staring at the Facebook wedge of the pie chart. So that's why we need to use graphs that are good for humans, because our brains, even though the pie chart, it looks colorful, it looks pretty, it just doesn't, actually communicate the data to us that well. We have a question from Ravi in the chat. Do you need access to Azure Cloud? No, you don't. All you're going to need for this is Visual Studio Code or an editor of your choice. I'm going to be using VS Code with the Python extension installed today. There's a link on how to do that on the additional resources that Sarah has shared out. And that's all you're going to need. You can grab the data if you want to follow along with this from the link to my GitHub account as well. So one last thing before we jump on to talking about making some graphs. Do some nice things like this is an etiquette thing, and it just makes your graphs a lot more easy to follow along, because I can often forget to put on axes titles and a chart title. It's going to tell you actually if these are percentage of market share visitors, is this the number of market share visitors? The title is going to give you the overall context. It's from November 2017. Okay, that's several years ago. Maybe not that relevant today. Not sure. So you have that rest of that context that's communicated. And that's really important to have for all your data, because data is just a way to represent the world. And it's a very concise way to represent the world. But if we take it out of context, it's basically useless. So today we've got our data that we were working with last week. And we have been taming today's data already last week with the CSV library in Python, NumPy, and Pandas. And we're going to be working on some of those things that we did last week, utilizing what we already did to pull out that data. But if you weren't here last week, don't worry. It's just two bits of data next to each other, and it doesn't matter if you're unfamiliar with the data or the context. So we're using green data today because it's Green Data Month, but if that's not your area of expertise, don't worry. Some of this is not mine. Koala data observations are not my area of expertise, but we're using it for a demonstration because it's Green Data Month in the Reactor. So with having said all that, let's get started on making some graphs. So I'm going to need to jump to my other screen because of our technical difficulties. I haven't quite got all my screens together. So let me just grab this one for us. Come here, screen. Okay. So first up, let's actually put this one up here so we can get back to our slides later. Okay, so first up, we're going to be making a simple scatter plot. This one's not going to look particularly exciting, but I do want to start with something basic to get us going. So we are going to be looking at our data first from the data set called UQ Tesla batteries. And this is a battery that is used by the University of Queensland to store energy to stabilize the grid. So it's kind of, a research project to do that, but also a way that, helps sustain the grid with additional green power resources. So that's pretty cool. I love green electricity. And so we're going to start off with that one, and just going to plot a nice, simple scatter plot with this one. But first up, we're going to get all of our data from last week back in. So we're starting off by just reading in our data. If you missed this last week, you can go back and watch that. We're just going to get the data from a TXT or from text. And we're saying it's TXT, please split it up based on the commas. And then we are going to have 2 different parts that we're going to cut out and plot against each other. So I'm just saying these are the indexes. So if you weren't here last week, I'm going to put, I'm going to print out my data just so you can have a look at that first. And then we've got to set our Python interpreter to Raven. Yes, I am using a Mac, and yeah, but Microsoft is for everybody, whether you're, a Windows user. Yes, thank you, Jack. We will make the text a bit bigger. Whether you're a Windows user, a Linux user, or a Mac user, Microsoft is happy to have you all, including me, using it here on my live stream. But there's a lot of developers out there in the world using Macs, and I think, Microsoft was very happy for me to use a Mac because it's one of the authentic programming experiences. So here is our data, which I've just printed out. We've got a bunch of nans because they're columns that were not numbers, and we've got a bunch of other bits of data. And the headings that we're going to be looking at today are the imported data, the imported electricity and the exported electricity. So how much electricity came in and how much electricity went back out. I hope that is big enough for you all. And yeah, we just want to plot that to see what it looks like. Is there any sort of trend or anything that would be good to know about? And to plot this, it's going to be really nice and easy. So we've got these 2 slices. So this is going to be a vertical slice. So this is just going to get us the column that has the imported electricity. And this is just going to get us the column that has the exported electricity, which we covered on how to do last week. And
Hi,
now,
Renee. Sorry to interrupt. Is there any chance you could make the text slightly bigger, zoom in slightly?
More bigger? I have made it much bigger. Since
you did
Jack
already?
has requested. Okay. Yes.
Great. Thank you. Sorry,
No.
Jack, I didn't know that was a recent question.
Cool. Yeah,
Thanks.
Thank you, everyone. Okie dokie. So hopefully you can all see that. Someone tell me in the comments if it's too big or too small now. But yes, now that we've got this all ready to go, I'm going to do our plotting. Just for this one, I'm just going to put this here so we can see it right next to each other. We're importing Matplotlib PyPlot, and we're going to import it as PLT, which is just a convention that people have set up. So if you're looking on the internet for help with this and you see plt.plot or plt.scatter, that's short for PyPlot in Matplotlib. So let's run it and see what it looks like. We should get rid of this print because that's just long and we don't need that. Let's do it again. And there we go. We have our first scatter plot. It's just a lot of dots on this line. And we can see that the electricity that comes in, basically it's linear. It goes out at the same rate. Some is lost to usage, but for the most part, it's just all there. So that's our very first scatter plot. But that's not very interesting because it looks like a line, and we kind of could have guessed that was going to be the case. So let's move on to plotting some koala data because that's much cuter and much more fun than the straight line electricity in equals electricity out. So yeah, let's get started with our pandas, what we used last week for our koala data. So we're going to start by preparing our data, and then in this next box down here, I'm going to plot the data. So we're importing pandas as PD. That's another convention that we have. And with pandas, we can just say, hey, give us these 2 columns by name, which is the convenience of pandas. We didn't have to work out what column that data was in because I had to count along on my Excel spreadsheet when I had it open to get these 15 and 16 and make sure I didn't get an off by 1 error. So here we go. We can just look up the data headings and we can just use that to get the data that we want. So what I'm going to plot here is the height of the tree that the koala was seen in and the height of the koala in the tree and see if there's any sort of interesting information to be gathered from that. So we've got those 2 columns. So this is all basically making a list of data, kind of like, or whatever, something like that. And then another list of data that has, some other features, something like this. And they're not all in lists. They are in, there might be a list. They might be a data frame for pandas. They might be a NumPy array. But at the end of the day, they're a way of having a collection of data, one-dimensional data, two-dimensional data over the 2 lists. So 1D each, 1 dimension each. So that's what we've got here. So we've got our data. It'll print out. It won't print out our koala highlights, but koala heights. But just so you can have a look at what the data looks like, let's print out just this second chunk of data. And we've got all of these koala heights. So let's turn those into a plot now. So once again, I'm going to import pyplot as PLT from Matplotlib. And I'm going to then create a scatter plot with the koala heights as the x-axis and the tree heights as the y-axis. And let's run that. Here we go. And we get something that looks like this. So we can say, okay, well, sometimes the tree is really tall, but they haven't moved up the tree. But that seems to be kind of an outlier. I don't know if that was a sick koala. I don't actually know very much about koalas. I just think they're cute. So that's why we have this data. But, that might mean something to you if you are a koala data expert. And you could say these are outliers, or these are koalas that were climbing up a tree, or there are koalas that are sick. Maybe it means something to you. So that's why it's useful to visualize your data, and you can tell your story that you see from your expertise. But as we said earlier, we do need to do our etiquette and say what the chart is. So I'm just going to call this koala tree position versus tree height. So how far up is that koala for the chart title? And then I'm going to add an X and Y title as well. I'm just doing it that the headings that there are in the file that we're using, but you could name it anything that you wanted that was relevant, and to note those meters, the units, or whatever you're using. So if we do that, now we have ping, we have this koala position and tree height, and we have our labels for the axes. So much more informative. Okay, so let's take a look at bar charts up next. So we've done our scatter plots, and they're a great way to have our 2 dimensions of data here, and spread them out of numerical data, that should be noted. But we're going to move on to bar charts, and they're great ways for showing numerical data for categories. And they can be vertical or horizontal. So we're going to cover both of those today. So let us take a look. So more koala time. So this time I want to plot the categories, which are going to be the local government area in which the koalas were spotted, and then how many koala sightings there were in that area. So I'm going to get to do a little bit of pandas fun to get this happening. And let's get that going. So I'm going to start by getting our koala data again, which we've done above, but I just want to do it here so it's clear. And if you want to grab just a specific one of these, you can. You don't have to grab all of the parts. Okay, so I'm going to introduce a new line, which I'm going to use some magic panda stuff that I've only learned in preparing for this. I haven't actually used pandas heaps in my career, but it's really useful. And if you go out to find out how to do something, it will probably be there, and you can do that thing with ease. So I wanted to count up how many koala sightings there were. So I needed basically to group up each, all the sightings based on where they were seen. So whether it's on the Gold Coast or in Brisbane or whatever, I want those in a group. And then I want to count up how many there are for that group. And that's all I want. All I want is this local government area, Gold Coast, for instance, there were, 53 sightings. So let's print that out and see what it looks like. Because we can just generate a series of data based on this. So from this, we can see that Brisbane City had 66 koala sightings, Gold Coast had 53, Ipswich had 39, etc. And yeah, really useful tool, Pandas. So I just said group by local government area. And then I just got it to count up how many ID tags there were, because it gives it everything an ID automatically. I could have counted it by something else, maybe tree height or anything I wanted, and it would have found how many unique tree heights, I believe, is what it would do. But I wanted to count each individual thing within that group. So I said, what I know is unique? The ID. So we're going to count those up and we get this list, which is super convenient because now I can make my graph out of it. So next up, into the plotting. So that's the preparing data area, and this is the plotting data area. So once again, here we get the Matplotlib PyPlot library, and we're going to get, so these kind of work like dictionaries, these data series in Pandas. So I can say the X, which is the keys. Maybe we shouldn't call it X. Let's not call it X. That's not very useful. These are the LGAs. Those are the keys of our thing that we had up here. So those are all those suburb names. And then we want the koala sighting values. Okay, so we get, these will be our counts. I'm not calling Y. You could call these X and Y, but this will be much clearer. And unlike dictionaries, when you do the values, it doesn't have the little brackets after it, which was interesting to learn. But that means it's an attribute of this. And I guess because the data does belong to it, that makes sense. Okay, so now we've got our data. Let us do the first part of making our chart, which is make it a vertical bar graph. And I haven't called these X and Y anymore. I've called them something much more clear. So let's do that. So we get our bar chart, and it's okay-ish. It doesn't look super great. Firstly, I haven't put any chart titles and things on it. But also it looks, you can't read anything here. So that's not ideal. So let's fix some things. So firstly, let's give it some titles for things. So ping, that's a bit better. Now we know what these things are at least. And okay, let's deal with the real issue here. I think the key thing is that these are illegible. So I'm going to say, let's turn them on a 45-degree angle. So I can say, okay, turn these what are called X ticks, these labels, where we want to rotate them 45 degrees. So here we go. Much better immediately. So super useful. And also I hadn't made it clear, but yeah, when you use Jupyter Notebooks, you can just have your graphs appear right below the code that you're making it. It's really great. When you're experimenting with things, rather than generating out 8,000 different files of you trying to work out how to make all of these rotations and titles and things correct. So really useful if you're doing that. And yeah, so I think that's looking pretty good now. There's other things you can of course do. You can of course change the colors, and there's so many things you can do, but we don't have heaps of time here today. So I'm just going to leave it with those default colors. And I'm going to show you one thing we can do to save this for later, because actually how I kind of started using Matplotlib is actually in my honors thesis when I was doing machine learning for renewable energy. So I do like green data already and using Python with it. And so yeah, I'm very excited about this part of the series. But what I was doing was modeling a bunch of things, and I would just leave running overnight my machine learning things. And I wanted to wake up in the morning to have all of my charts made so I could see how my different experiments with the data for the renewable energy model that I made had gone overnight. So normally when you're not using Jupyter Notebooks, you would say plot.show after all of this, and that would bring up a little pop-up box that would show your image. We don't have to do that because we're using Jupyter Notebooks, so it's good to note that we would need to do that if you're just using it in regular Python in a file. But if you would like to make this file get saved, and then you can just run your code and walk away and come back and have 100 different graphs generated if that's what you need, then this is how you can do that. You can say plot save fig, and then you give it your file name. So I'm going to say koala locations, and then you can add this if you want, which just saves space around your image, but you don't need it if you don't want it. You need to put this save fig before a show, because otherwise your image that you generate will be empty, because once you show it, it kind of clears the slate ready for the next thing. So make sure you save it to the file and then show it, so it will work. So let's give that a go. So we get our koalas, we still get it shown here, but we also get our koala locations graph for later. So super convenient. I liked it during my honors thesis because I just wake up in the morning to a bunch of graphs, and it was delightful. So I will show you another very small change for this. I'm going to get rid of our unnecessary things for today. We don't need to turn everything into a file because my computer would be full of files. But I would like to now make this into a horizontal graph. It should say horizontal. So instead of going up, we want it to go left and right. And very easy to make that difference. All I'm going to do is add an H here, bar H, and here we go. It's our beautiful horizontal graph. It hasn't even, I don't know if you can change the orientation of your ticks on the left-hand side. Maybe it just does, the one that will, we have that's for our, of course, it's for our bottom axis. So they're still in an angle. I think we don't need that. You could obviously change your left-hand side, your y-axis as well. But here we go. Looking good there. And I think that'd be a good orientation because it means that these line up easily with the data that you're showing. So that's how to make our column graphs. Please ask any questions as you go throughout. And let's next have a look at the final graph of the day, which is going to be our line chart. And I feel like we're all familiar with a line chart. They're the ones you see of the stock market doing something, or things going up and down over time, like this temperature chart one here. And they're really good for plotting sequential data. So often people will use a line chart because it seems to be the default sometimes, and they might use it for something like this. And it would connect the dots between these bar charts. But it doesn't really make sense because two-seaters and compact and mid-sized cars, from this example, are not in an order. It doesn't make sense for them to be joined. So it implies things that the data shouldn't imply. So when you're doing something with a time series or something that data is actually sequential, that's when you can use a line chart. But otherwise, be going with the bar chart instead. So let's take a look at how we can make a line chart. Okay. So this one, we are going to be using the ocean surface temperature for Cairns that we were using last time. That's in our CSV file. So that's a basic looking file. It looks like this. Not many lines, bits of data. It's just the date and time and the temperature. And that seems perfect for plotting a line chart for me. So let's start by getting all of our data. So I'm going to start by adding we're not going to use statistics today, actually, because we are not making any means and medians, because we are graphing things which need to reveal all that more information. So unlike last week. And we're going to open up our file, like we did last week with the CSV library, which a quick Google Bing will give you the information for in a second, which I use nearly every time I do this, because I'm like, I don't want to mess up, calling these CSV readers. If I really committed to thinking about it, I'm sure I'd get it, but it's just easier to check. The internet holds all the information for me. So we're going to create a CSV reader object. We're going to start by reading the header line, by popping that off, and we don't want that for the rest of our data collection. And then one at a time, we're going to read one line. We're going to grab that date time, and we're going to grab that temperature. And what I want to do is I want to pop them into some lists, so I can then have 2 axes, times and temperatures to plot. So all I'm going to do is inside here, I'm going to get those 2 bits of data, and I'm going to just append them to these lists. I'm going to turn the temperature into a float, because they're both strings at the moment. I could go and turn this into a date time object in Python, but for the purposes of this, we kind of just want a linear progression of those strings anyway at equal intervals. We know this data is all at equal intervals, so it's actually not going to be an important. And we'll just use them as labels then. But if your data was sporadic, you probably want to convert them to a numerical piece of data so it could get plotted at appropriate spacing. So now we've got that. I'm going to jump into my next box to do our plotting. This one's a little more complicated looking. You could easily plot a simple line graph, but what I'm going to do with this one, there's a lot of bits of data. So I'm actually just going to plot the first 100 bits of data. But even with that, there's a lot of labels, which I'll show you in a second. So I'm going to start actually by making this a really wide graph. So you can set the dimensions of your space. So I'm going to make it only, I think these might be in inches, 6 inches tall and 20 inches wide potentially. We'll find out when we run it. Maybe it's centimeters, I'm not sure. And then I'm going to create this here. So far we've just been saying plot this, plot that, but this time actually getting references to this plot subplots. And we're going to have a little look at subplots next week, because you can actually have many tiled plots and overlaying plots. And by using subplots, you get to have handles on these things rather than just saying, plot this to the screen and we're going to be over and done with it. We can have these handles and we can work out how to lay things out. And that means I can specifically set how we're going to set the labels for this. So that's why we're doing the subplots here today. So as I said, I'm just going to do the first 100 while we're preparing this, and maybe then I'll run the last 100 while we the full set, which is thousands and thousands of lines. So it takes like 30 seconds to run while I answer any questions. So we've got our first 100, and then I'm going to start by plotting times and temps. Yeah. And I'm going to rotate our ticks by 90 degrees. So they're fully side on. So let's run that and see what we get so far. Oh, we get an error. Okay, have we not run this one yet? We run this one. That's what we've got to do first. There we go. Now we can run the next one. We have a lot of data anyway. And here we go. Here's our chart. It hasn't come out as wide as I thought it was going to come out for some reason. We'll have a play with that in a second. But as you can see, there's a lot of labels here, which is too many labels for us. Let's see if we can make our thing get wider. Let's crank it up to 40. No, okay. I think with our subplot, something's going on. Let's chuck it after here and see if we get lucky with that. Here we go. Our giant plot is what we want. It's very wide now, and we probably just want to put it back to 20 as I had initially expected it to be. Hopefully this will be kind to us and still let us do all our labeling things. We'll find out in a second. Okay, so that's still too many tick marks. That is way more than we actually want to read. So I'm going to go through and I'm going to make some labels. Just for the purpose of this, I'm just going to say, can we please have the every 10th label? And there's so many different ways to do anything in Matplotlib, so there might be a better way. And if you know it, please put it in the chat. But here's what I'm going to do for today. And just kind of a way to show you, you could do whatever you wanted with the labels. And what I'm going to do is I'm going to create a bunch of labels. And here's what I'm going to do. I'm going to say, okay, let's go through all of the times, but I don't want to have all of the times. I'm going to grab that position of that time. So, it might be the 0th or it might be the 57th time. If that number of time is, maybe 0 or 10 or 20, 30, then when you divide it by 10, we get a remainder of 0. So if it's divisible by 10, this modulo symbol, I'm going to say append the time to my list of labels. And if it's not, append a blank thing so I can actually read the rest of the labels. And this isn't like going to be the neatest way of doing it, but you could do a lot of stuff by just playing around and messing with your labels and then setting them. So now I'm going to set those labels and put them on the chart. And let's have a run of that and see how we go. Nope. Okay. Something I've done with the order of this means that we're going to need to have it in this order. So here we go. Okay. Forget about our really wide graph. That's not going to happen for us because of the subplot things. And I think we need special code for that. But you could change the width of your regular graph if you want, as I showed you before. Here we go. So we still got all these tick marks, which I'm actually not going to cover on how to get rid of tonight, but we can see we can do whatever we want with our labels, and it's become much, much clearer already. We do kind of have these weird blank parts at the start and end of those, which you kind of don't normally see when you're dealing with time series data. So I'm actually going to pop another thing on there to be like, okay, we want the margins around this to be 0 on the x-axis, so we don't have that extra padding. So we can get rid of that. And here we go. It's our time series graph with our custom labels. And maybe you don't even want the times that are on there from your data. Maybe you just want to go through and find one date from the 24th, one date from the 25th, one date from the 26th, and label those. So you could really be doing anything you want with your labels there. And that's kind of why Matplotlib is a really useful tool for making whatever you want happen. Because I love Excel, and if I'm doing a basic graph, I'm absolutely going to go to Excel first if I just want to plot a couple of different parts of data against each other. But when I want to make something custom and I want to make a bunch of them, especially, then I will definitely go to Matplotlib to get things working. So while we're going to wait for it to run and make the full graph because it looks pretty good. But while we do that, I'm going to wait for you to ask any questions that you might have before we sign off for tonight. So let's kick that up and running. Is it? Oh, we need to run. Let's run it all again. And then do pop any questions you have in the chat while we wait for this to go. It's slowly happening. We did have a question or a comment, I think, up here about creating a collection of videos on YouTube. Oh, it's still got a lot of things there, but I will find that question. Would be great if a playlist can be created to group the videos as a series. You could also go to my personal website, reneenoble.com, and there is a page for In the Code Garden there, and it lists all of the episodes, including what they cover in them. But I think I have started my own YouTube collection, which I will add these videos to shortly as well, so you can catch up on them if you missed out. But the best place to go to catch them all is reneenoble.com, and then go to the page for In the Code Garden from the current series at the top. So, well, these labels at the bottom, they're not looking great because there's still way too many, and we could probably, let's possibly up it to way bigger. Let's say 1,000 and see what happens. But we did see that it made a really interesting graph. And the great thing about Matplotlib and Pandas and NumPy is that you can plot really, really big data. And Excel is great for even quite very large data, but at some point it gets way too big and Excel will have a bad time if you try and put that much data into it. But as we've seen, we've just been able to create this, and it only took us about 10 seconds to make this very, very detailed graph. If you can see that depth and of those lines going in there, there's a lot of detail on how even just within a day, overnight, how that temperature is changing. So you can get a lot of detail in these graphs. So we have. Can you put a marker on each point? You can. I don't have that off the top of my head how to do it. I know I did it in my Wordle series on how to make a marker for each letter of the alphabet when we made a plot of the frequency of the letters in the alphabet. But I'm going to put that in the show for next week, Sarah, so you can catch it then, so we can have more information on how to have those markers there as well, because we're going to have some more complicated graphs next week. So having those kinds of markings is sometimes really useful. So if we don't have any other questions, I'm going to tell you to come to next week's episode of In the Code Garden, which will be the last week of this data science, big introduction to data science and visualization series. We're digging below the surface with 3D graphing and combining visualizations in Matplotlib. So we're going to have some 3D graphs, and we're going to have some of those combination graphs. So maybe we'll be, have a couple of different lines on the same graph, or, different labeling structures. If you want to sign up for that, go to this link on the screen, which Sarah has also popped into the chat for today. So you can sign up, and so we can see you next week. And I hope Sarah's going to come back. There she is.
I am. I'm here. Thank you, Renee. Just letting you finish up there. As Renee mentioned, we've got that link there to the Code Garden series, and I believe someone else mentioned checking out previous episodes. You can do so via that link or via the YouTube channel. You just click the Reactor YouTube channel, and you can search the series by name on the main page there. And we've also added in the link to our survey with the event code 16314. If you have time to fill that out, that would be great. And we will leave it there for today. So thank you so much, Renee, and thank you to everyone for staying tuned in, even though we started about 10 minutes late today. We will see you next week. Have a good rest of your afternoon, evening, or morning, and we'll see you next time. Thank you.
Thanks, everyone. See you next week.
Bye.